The cosmos has always been a place of whispers, secrets carried on waves of light and shadow, stretching across distances so vast they defy comprehension. Out there, in the silent expanse where stars are born and die, a tiny machine drifts. Humanity's oldest messenger, Voyager 1, a relic from an era when we still dreamed in analog and hoped in starlight. Launched in 1977, when the world was grooving to disco and marveling at the first Star Wars, this small spacecraft, no bigger than a car, was sent to explore the planets. But it did so much more. It became our farthest traveler, slipping beyond the reach of our sun's warmth into the cold, uncharted void of interstellar space. Over 15 billion miles from home, it still speaks to us. Its voice a faint murmur carried across 22 hours of light-speed delay. Each message is a miracle, a testament to human ingenuity, a whisper from the edge of forever. But now, Voyager has heard something else, something moving in the dark, something that shouldn't be there. It's not a planet, not a star, not anything we know. And as its ancient instruments hum with strange new data, a question burns. Has Voyager stumbled upon a secret the universe wasn't ready to share? Imagine the loneliness of it. A machine, built by hands long retired, floating through a darkness so complete, it feels like the absence of everything. Voyager 1 wasn't meant to last this long. Its creators thought its nuclear heart, powered by decaying plutonium, would flicker out by the early 2000s. Yet here it is, in 2025, still alive, still listening. Its 1970s circuits humming with purpose. It carries tools that seem quaint now. Magnetometers to feel the invisible tug of cosmic fields, cosmic ray detectors to catch the fleeting sparks of distant energies, plasma sensors to taste the electric breath of space. These were built to study Jupiter and Saturn, to send back grainy images of swirling storms and icy rings. But now, far beyond the planets, they've become something else. Humanity's first senses in a realm we barely understand. Voyager also carries a golden record, a cosmic postcard etched with the sounds of Earth, laughter, music, greetings in languages that may outlive us all. It was a message for anyone, or anything, that might find it in a million years. But what if that message has already been heard? What if, out there in the void, something answered? It began with a flicker, a tiny anomaly in the endless stream of data. Voyager sends home. Scientists at NASA's Jet Propulsion Laboratory, hunched over monitors in a world of coffee cups and deadlines, barely noticed it at first. Space is noisy, after all, full of dust, radiation, and the occasional odd blip that means nothing. But this was different. Dr. Eliza Karna, a mission specialist with tired eyes and a heart full of wonder, described it as shouting into a canyon for decades and hearing, at last, a faint echo in return. The signal was subtle, a reflection of light caught by Voyager's aging sensors, so faint it could have been dismissed as a glitch. But then it moved. Not the chaotic tumble of a rock or the lazy drift of cosmic debris, but a smooth, deliberate glide, like a bird carving a path through the sky. It curved, it accelerated, it danced through the void with purpose. The plasma sensors stirred, registering a shift that felt intentional, focused, alive. This wasn't noise, this wasn't random. Something was out there, moving in a way that defied everything we know about the physics of space. The team at JPL leaned closer to their screens, hearts pounding, as the data painted a picture they couldn't quite believe. Systems analyst Carlo Romero, a man who preferred numbers to speculation, couldn't shake the image that came to mind. A drone, not a rock, moving with intention, as if it knew where it was going. In the vast emptiness between stars, things don't just move like that. Gravity pulls, solar winds push. But this was different. Too precise, too controlled. The realization hit like a cold wave. Whatever Voyager had found, it wasn't one of ours. The void, once thought empty, suddenly felt crowded, alive with possibilities both thrilling and terrifying. Scientists began to whisper questions they'd never dared ask before. Was this a machine? A probe? A relic of some distant intelligence? Or was it something else entirely? Something that didn't fit into the neat boxes of human understanding? As the data streamed in, each byte a breadcrumb leading deeper into the unknown, NASA found itself staring into a mystery that could rewrite everything we thought we knew about the universe. The days that followed were a blur of sleepless nights and frantic calculations. The team ran through every possibility they could imagine. Could it be a comet? No. There was no icy tail, no telltale glow. An asteroid? Too small, too precise in its movements. A distant moon? Or a wandering star? And yet, the line between them blurs, especially when you look at the battlefields of today. Consider Ukraine, where Starlink has become more than a tool. It's a lifeline. Elon Musk himself has called it the backbone of the Ukrainian army, a network that keeps their front lines connected in the chaos of war. Without it, he's warned, their defenses could collapse. Poland foots a $50 million bill to keep Starlink running for Ukraine, a civilian service turned military asset. And Musk has flexed that power, briefly switching off Starlink to prove a point, sending ripples through a conflict that hinges on bytes and bandwidth. In Gaza, the story is different, but no less charged. Amid an internet blackout imposed by Israel, Starlink was allowed to operate in a single hospital. After months of negotiation, a faint signal of hope for humanitarian workers in a sea of silence. Israel hesitates to expand access, wary that the same technology could be wielded against them. These are not just satellites, they're pawns in a global chess game, where a private company like SpaceX holds a king's power. This is where the heart of the mystery lies. When a corporation controls the tech that can sway wars, who truly holds the reins? Starshield might be SpaceX's attempt to carve out a separate space for military use, to untangle Starlink's commercial glow from the grim realities of defense. But as long as both systems share the same tech, the same lasers, the same orbits, that separation feels like a fiction, one that could have consequences we're only beginning to grasp. The sky is no longer just a place of wonder. It's a contested domain, a frontier where ambition and danger collide. Starlink and Starshield are reshaping our world, but they're also crowding our orbits, filling them with machines that could outlast their makers. Astronomers already lament the light pollution from Starlink's swarm, streaks of reflected sunlight that drown out the stars. Radio telescopes are blinded by emissions leaking from these satellites, with studies showing radiation levels 32 times stronger than earlier generations, flouting international regulations. And it's not just SpaceX. China's Ji-Wang constellation plans to add 13,000 satellites, while Amazon and OneWeb plot their own orbital empires. The result? A sky so congested that Starlink satellites adjusted their positions 100,500 times in a single year to avoid collisions. One maneuver every 5 minutes. Space junk, rocket parts, derelict spacecraft, fragments as small as a centimeter, zips through low Earth orbit at 25,000 kilometers per hour. Faster than a bullet, each piece a potential trigger for disaster. In 1978, NASA scientist Don Kessler warned of a chain reaction, one collision spawning debris that causes more collisions, until our orbit becomes a graveyard of shattered metal. This is Kessler syndrome, a doomsday scenario where the International Space Station, the Hubble telescope, every satellite we rely on could be obliterated, trapping us beneath a shell of our own making, unable to launch, unable to explore. And yet, the satellites keep coming, each one a gamble in a sky running out of room. The stars we once gazed at with wonder are now joined by a swarm of machines, each one a testament to human ambition and a reminder of our recklessness. As SpaceX's Starlink and Starshield constellations grow, they're not just reshaping our skies. They're rewriting the rules of power, war, and exploration. But what happens when these satellites, these marvels of engineering, become more than tools? What happens when they become weapons, targets, or ticking time bombs in a sky already brimming with danger? The threat isn't just in the satellites themselves, but in the debris they leave behind, the conflicts they enable, and the delicate balance they disrupt. Let's dive deeper into this orbital battlefield, where the line between progress and peril is as thin as a laser beam, and where the future of our planet's skies hangs in a fragile dance with destiny. The congestion in low Earth orbit is no longer a distant worry. It's a crisis unfolding before our eyes. With over 12,000 satellites already circling our planet, and plans for tens of thousands more, the sky is becoming a cosmic highway at rush hour. Starlink alone made 100,500 maneuvers in a single year to dodge debris and other satellites, one adjustment every 5 minutes. But in 2024, SpaceX quietly shifted Starlink's collision avoidance threshold from 1 in 10,000 to 1 in 1 million, a 100-fold increase in caution. Now, these satellites reposition every 30 seconds, a frenetic ballet to stay safe in a sky littered with over 25,000 trackable objects and a million smaller fragments, all hurtling at 25,000 kilometers per hour. A fleck of paint at that speed could punch through a satellite's hull. A larger piece could trigger catastrophe. This is the specter of Kessler syndrome, named after NASA scientist Don Kessler, who in 1978 foresaw a chain reaction of collisions that could render our orbits unusable. Imagine a single crash spawning a cloud of debris, each shard smashing into another satellite, creating more fragments until the sky is a blizzard of shrapnel. The International Space Station, the Hubble telescope, every communication network we rely on, gone. We'd be prisoners on our own planet, trapped beneath a shell of our own making, unable to launch new missions for decades, perhaps centuries. And the threat isn't just accidental. In 2021, Russia tested an anti-satellite missile, obliterating one of its own satellites and scattering 1,500 trackable pieces of debris across low Earth orbit. The U.S. condemned it as reckless, but the damage was done, a warning shot in a new kind of warfare, one fought not on land or sea, but in the silent void above. This is the world of counterspace, where satellites aren't just tools, but targets. Russia, despite lagging in satellite production with only 220 in orbit by 2023, is flexing its muscle in other ways. Whispers of a nuclear anti-satellite weapon surfaced in 2024, a chilling prospect that could fry electronics across vast swaths of orbit. Even without nukes, Russia's arsenal includes lasers, ground-launched missiles, and electronic warfare systems, designed to blind or disable satellites like Starshield. The 2021 test of their A-235 Noodle missile wasn't just a flex, it was a message. The sky is no one's sanctuary, and Russia isn't alone. China's Ji-Wang constellation mirrors Starlink's ambitions, with 13,000 satellites planned, but their motives are as much strategic as commercial. The U.S., through Starshield, is building a fortress in orbit, but it's a fortress that could become a flashpoint. If a satellite, Starlink or Starshield, becomes a valid military target, what stops a nation from striking first? And what happens when the debris from that strike sparks the very chain reaction Kessler feared? The irony is stark. The same technology that connects us, that beams education to remote villages and aid to disaster zones, could also lock us out of space forever. Starshield's secrecy only deepens the unease. Its modular design, capable of swapping payloads for surveillance or missile tracking, makes it a wild card in this high-stakes game. And with Starlink's tech underpinning it, the question lingers. Can a civilian network ever truly be separate from its military shadow? Even if we dodge the bullet of Kessler syndrome, there's another problem. What happens when these satellites die? Starlink and Starshield satellites have a lifespan of 4 to 5 years, after which they're meant to burn up in Earth's atmosphere, leaving no trace. SpaceX calls them demisable, assuring us that any fragments that survive re-entry have negligible impact energy. But the truth is messier. In recent years, chunks of space junk have crashed in Kenya and Uganda, scattering wreckage across 40 kilometers with no warning. These weren't Starlink satellites, but they're a grim reminder that demisable isn't a guarantee. With thousands more satellites planned, the risk grows. A 2024 study in Nature warned that many operators, including SpaceX, lack clear plans for disposing of their aging fleets. Even when satellites do burn up, they leave a hidden scar. As they incinerate, their aluminum bodies release nanoparticles of aluminum oxide into the upper atmosphere, where they can linger for decades, eating away at the ozone layer. A single 800-kilogram Starlink satellite can produce 30 kilograms of these particles, undoing years of progress since the 1979 ban on CFCs. The ozone buff layer, our shield against ultraviolet radiation, is fragile, and the more satellites we launch, the more we gamble with it. Commercial planes, too, face risks from uncontrolled re-entries, flying through skies where debris could strike without warning. The promise of connectivity comes with a price, one measured not just in dollars, but in the health of our planet and the safety of its inhabitants. This isn't just about technology, it's about power, responsibility, and the future we're building. SpaceX, with Starlink and Starshield, sits at the heart of this new space race, a private company wielding influence once reserved for nations. Their satellites have transformed lives, from remote classrooms to war-torn front lines. But they've also blurred the lines between corporate innovation and military might. In Ukraine, Starlink's role as a military lifeline raises questions about who controls the tools of war. In Gaza, its limited presence underscores the delicate dance of geopolitics. Starshield, with its classified missions, only deepens the mystery, pulling SpaceX into debates it was never meant to join. And yet, the bigger picture is even more daunting. The sky is finite, a shared resource we're filling with machines, debris, and ambition. If we don't act, through regulation, innovation, or sheer restraint, we risk turning space into a junkyard, a place where dreams of exploration crash against the wreckage of our own making. Other players, from China to Amazon, are racing to claim their slice of orbit. But SpaceX, as the frontrunner, bears a unique burden. How will they balance profit with responsibility? How will they ensure the skies remain open for the generations to come? As we stand on the edge of this new frontier, the stars feel both closer and further away. Starlink and Starshield are monuments to what we can achieve, connecting the world, defending nations, pushing the boundaries of what's possible. But they're also warnings, reminders that every leap forward carries a shadow. The sky is no longer just a canvas for our dreams. It's a mirror reflecting our choices, our conflicts, our carelessness. Can we keep it a place of wonder, a gateway to the cosmos? Or will we let it become a graveyard of our ambitions? The answer lies not just with SpaceX, but with all of us, governments, companies, dreamers, who look up and imagine what's next. Let's hope we choose wisely, so that the skies remain a place where we can still chase the stars, not just dodge the debris.